So your quiz is on 6.5 and 6.6. So you're using long division, synthetic division, and then solving your equations that deal with fractions. We're going to start looking at long division. For your long division, you're going to have something divided by something. That binomial that you're dividing by, that's going on the outside of your division house. The first part, that polynomial, goes on the inside. So if you look at example 1, you have x cubed plus x squared minus 11x plus 10 divided by x minus 2. That x minus 2 is going to go on the outside. The x cubed plus x squared minus 11x plus 10 goes on the inside. You're going to start with looking at the first term in each part. So that x and that x cubed. Ask yourself, x times what is x cubed? That's x squared, so that goes above the x cubed. You're going to multiply whatever you put above that x cubed by the two terms on the outside and put them underneath. So x squared times x is x cubed. X squared times negative 2 is negative 2x squared. From here, subtract these, distribute your negative, it becomes positive, and everything switches the signs. So your x cubes cancel. X squared plus 2x squared is 3x squared, and you bring your next term down, which is at negative 11x. You're going to start all over again. So compare the x on the outside with the 3x squared on the inside. X times what is 3x squared? That's 3x, so that goes above. Multiply the 3x by the x and then negative 2. 3x times x is 3x squared. 3x times negative 2 is negative 6x. Subtract these, distribute your negative. You're adding the opposites. The 3x squareds cancel. Negative 11x plus 6x is negative 5x. And you bring down that next term, which is 10. From here, start all over again. X times what is negative 5x? That's negative 5. Multiply the negative 5 times x. That's negative 5x. Multiply the negative 5 times the negative 2. That's positive 10. You are going to subtract these, distribute the negative, change your signs on everything. Your 5x's cancel, your 10's cancel, so you do not have anything as a remainder. So your only answer for this is that x squared plus 3x minus 5. For number 2, we have 2x cubed plus 5x squared plus 9 plus 9 divided by x plus 3. If you look here, you need to make sure that all of your powers from highest to lowest are represented. You start with the x cubed. You have an x squared, however, you're missing an x. So you're going to have to add in a 0x in between the 5x squared and the 9. So you're going to put that x plus 3 on the outside. On the inside, you're going to have the 2x cubed plus 5x squared plus 0x plus 9. We put that 0x in there to represent, again, all of those values from the highest power to the power of 0. Do the same thing you did with the question before this. Compare the two first terms in each part. X times what is 2x cubed? That's 2x squared. So multiply the 2x squared by x and 3. That gives you 2x cubed plus 6x squared. Subtract these. Distribute your negative. Change your signs. Your 2x cubes cancel. 5x squared minus 6x squared is negative x squared. Bring down your next term, which is that 0x. Start all over again. X times what is negative x squared? That's negative x. Multiply it by the x plus 3. That's negative x squared minus 3x. Subtract these. Distribute your negative. Change your signs. Your x squareds cancel. 0x plus 3x is 3x. You drop down that next term. It's 9. You're working with the x and the 3x now. X times what is 3x? That's plus 3. So 3 gets multiplied. You have 3x plus 9. You subtract. Distribute your negative. Your 9's cancel. Your 3x's cancel. So you have a remainder of 0. So your answer for this one is just the 2x squared minus x plus 3. For your next one, number 3, you have x cubed minus 2x squared plus 3x plus 22 divided by x plus 2. So that x plus 2 is going to go on the outside. Your x cubed minus 2x squared plus 3x plus 22 goes on your inside. Ask yourself, x times what is x cubed? That's x squared, so that goes up top. You multiply, you get x cubed plus 2x squared. You're going to subtract these, distribute your negative, switch your signs. That gives you negative 4x squared left over. You drop down the next term, which is at positive 3x. Ask yourself, x times what is negative 4x squared? That's negative 4x. So negative 4x times x is negative 4x squared. Negative 4x times 2 is negative 8x. Add or subtract these, or add the opposites. Your 4x squareds cancel. 3x plus 8x is 11x. You drop down that next term, which is the 22. Ask yourself, x times what is 11x? That's 11. So 11 times x is 11x. 11 times 2 is 22. If we subtract these or distribute the negative, change your signs, your x values cancel, your constants cancel, so you have a remainder of 0. So our answer for this one is just x squared minus 4x plus 11. The next part of your review goes over synthetic division. When you work with synthetic division, that binomial has to have a coefficient on that x of 1. Additionally, you're going to set that binomial equal to 0 and solve for x. Whatever you get that x is equal to from that binomial, that's what's going to go on the outside of your synthetic division. Then your coefficients and constants from your highest degree to your lowest go on the other side of that number on the outside. So if we look at example 4, we have 3x squared minus 7x plus 4 divided by x plus 2. You have x squared, x, and your constant, so you're good with your powers. From here, we're going to take that x plus 2, set it equal to 0, and solve. Move your 2 over, subtract it from each side. You get that x is equal to negative 2. That negative 2 is going to be the number on the outside. On the inside, you're going to have your coefficients and your constants. So 3, negative 7, and 4. That first term comes down. So the 3 drops down. You multiply that term with the number outside. 3 times negative 2 is negative 6. Put that underneath your next number to the right of that 3 and combine it with those 2. So negative 7 minus 6 is negative 13. We then do the same thing again. So multiply your negative 13 with your negative 2. That's going to give you a positive 26. Add it with the 4. That gives you 30. That 30 is your remainder. The negative 13 is your constant. That 3 is going to get an x. So this gives you 3x minus 13 plus 30 over what you divided by, which is x plus 2. So if you're left with a remainder, that remainder has to go over that binomial that you divided by. In this case, it's the x plus 2, not just the negative 2. The negative 2 would not be the same thing. You have to put the x plus 2 in the denominator of that fraction that gives you your remainder. For number 5, you have x cubed plus 6x squared minus 3x minus 5 divided by x minus 3. If we take that x minus 3, set it equal to 0, and solve for x, we add the 3 over. That gives us that x is equal to 3. So the 3 is the number that's going to go on the outside. For our powers on our polynomial, we have 3, 2, 1, and our constant, so we're good. Our coefficients that are going to go to the right of that 3 are 1, 6, negative 3, and negative 5. Your 1 drops down. 1 times 3 is 3. Put it under the 6 and add it. 6 plus 3 is 9. 9 times 3 is 27. Add it with the negative 3. That gives you 24. From here, we multiply the 24 with the 3. That gives us 72. We add that with the negative 5, or subtract 5 from 72, and we're left with 67. So the 67 is your remainder, the 24 is your constant, the 9 gets an x, the 1 gets an x squared. So we just have x squared plus 9x plus 24 plus 67 over x minus 3. For example 6, we have 3x to the 4th power minus 15x squared plus 7x minus 9 divided by x minus 3. If we take that x minus 3 and set it equal to 0, we add that 3 over, and we get that x is equal to 3. So 3 is going to go on the outside. However, if we look at that polynomial, we have the power of 4 as our highest power. We are missing the power of 3. So you're going to have to add in a 0x cubed after that 3x to the 4th power, and in front of that negative 15x squared. So your coefficients that are going to go on the right of this 3 are going to be 3, 0, negative 15, 7, and negative 9. Your 3 on the inside drops down. 3 times 3 is 9. Add that with the 0, that gives you 9. 9 times 3 is 27. Your 27 minus 15 gives you 12. Oops, not there. Here. So multiply your 12 with the 3, that gives you 36. Add that 36 with the 7, that gives you 43. Multiply that now with the 3, that's 129. Put it underneath the negative 9 and add them. That gives you 120. So your 120 is your remainder. The 43 is your constant. 12 gets an x. 9 gets an x squared. 3 gets an x cubed. So this is 3x cubed plus 9x squared plus 12x plus 43 plus 120 over x minus 3. Now, if you had a remainder that was negative, you can write it as plus that negative number over what you divided by, or write it as minus a positive number over the number or the binomial that you divided by. It's totally up to you. And for 7 and 8, we're going to use synthetic division to determine whether the binomial is a factor. When we do this, we're going to do the same thing we did in the last section, except we're going to look solely at our remainder when we get our answer. Our remainder, if it is 0, then that binomial is a factor. If it's something other than 0, then that binomial is not a factor. So if we look at number 7, we're given x plus 2 with the polynomial x cubed minus 2x squared plus 3x plus 22. That x plus 2, if you set it equal to 0 and solve, you're going to get that x is equal to negative 2 because you just subtract the 2 over. So that negative 2 is going to go on the outside. On the inside, you're going to have 1, negative 2, 3, and 22. That 1 drops down. 1 times negative 2 is negative 2. Negative 2 plus negative 2 is negative 4. Times negative 2 is 8. 8 plus 3 is 11. 11 times negative 2 is negative 22. 22 minus 22 is 0. Since your remainder is 0, your x plus 2 is a factor. For number 8, you have x minus 1 with the polynomial x cubed plus x squared minus 3. For that x minus 1, if you set it equal to 0 and solve, you just get that x is equal to positive 1. So that 1 goes on the outside of your division. That polynomial, however, you have x cubed, you have x squared, but you do not have an x. So you need to add in that 0x after that x squared. From here, your coefficients are going to be 1, 1, 0, and negative 3. Your first 1 drops down. 1 times 1 is 1. You put it underneath your next one, add it, that gives you 2. 2 times 1 is 2. Put it underneath the 0 and add, that's 2. 2 times 1 is 2. Add it with the -3, that's -1. Look at your remainder. Your remainder is not 0, so that x minus 1 is not a factor. If we look at the next section, it tells us to use the remainder theorem to evaluate the following. With these, you're still using synthetic division, except you do not have to solve for what x is in order to put that on the outside. It gives you what you're using. Whatever's in the parentheses, that's p of whatever, is what's going on the outside. Like I said, you're going to use your synthetic division. Whatever your remainder is for these is what your p of something is. For example 9, you have to find p of -3 using p of x is equal to x squared minus 5x minus 9. So it gives us the number that's going on the outside, which is going to be that -3. Your x squared minus 5x minus 9 gives you your coefficients and your constant. All of your powers are represented from 2 to 0. So that's just going to give us a 1, a -5, and a -9. Your 1 drops down. 1 times -3 is -3. Add that with the -5. That gives you -8. Times -3 is positive 24. 24 minus 9 is 15. So your remainder is your answer. That 15 is your answer. So you're going to give that p of -3 is equal to 15. And yes, you need to put the p of -3. For number 10, you're finding p of 4 using p of x is equal to -x cubed plus 5x squared plus 3x. That 4 goes on the outside. Your polynomial is missing a constant. So you can plug in a plus 0 at the end of that, so that way you have all of your numbers represented. So you're going to have a -1, a 5, a 3, and a 0 on the outside in your synthetic division. Your -1 drops down. -1 times 4 is -4. Put that under the 5 and combine it with the 5. 5 minus 4 is 1. That 1 gets multiplied with the 4. Goes underneath the 3. You add those. You get 7. 7 times 4 is 28. That goes underneath the 0. You combine those. That's 28. So your remainder is the 28, which means p of 4 is 28. For 6.6, we're working with solving these equations that work with fractions. Remember with your proportions, so a fraction is equal to a portion, a fraction is equal to a fraction, you're just cross-multiplying and solving. If you have an actual equation that has fractions in it, find your least common denominator, multiply the entire equation by the least common denominator to cancel out those fractions, and just work with whole number terms. For 11, you have -3 over 8 is equal to 2 over x. If we cross-multiply these, since it's a fraction equal to a fraction, we're going to have -3x is equal to 16. Divide each side by that -3 to get x by itself, and you have that x is -16 over 3. For number 12, you have 2 over x plus 5 over 2x is equal to 1. Your least common denominator for this one is 2x. So we're going to multiply every term within that equation by 2x. So it's going to be 2x times 2 over x plus 2x times 5 over 2x is equal to 1 times 2x. Your 2x times 2 over x, your x's cancel, so it's just 2 times 2. Your 2x times 5 over 2, your 2x is cancel, so that's just 1 times 5. And 1 times 2x is 2x. If we multiply the 2 times 2, that gives us 4. The 1 times 5 is 5. So that's 9 is equal to 2x. We divide that 2 over to get x by itself, and we get that x is equal to 9 over 2. Remember with these two, when you're getting into more difficult things, when you have more than just the x in the denominator, it might be a good idea to take your least common denominator and set it not equal to 0 to see what x cannot be. Because if you get one of those answers that your x cannot equal, you have to state that that's an extraneous solution, which means it's a solution, but when you plug it in, it doesn't work. If we look at number 13, we have 5 plus x plus 1 over x minus 1 is equal to 3 plus 5x minus 3 over x minus 1. Your least common denominator for this one is x minus 1, which means if you set that equal to 0 or not equal to 0 and solve, x cannot equal positive 1. If you plugged in 1 anywhere you see the x in the denominator, it's going to give you 0 in the denominator. So if you get an answer that is 1, you know that that's an extraneous solution. If we multiply the entire equation by that x minus 1, this is going to give us 5 times x minus 1 plus x minus 1 times x plus 1 over x minus 1 is equal to 3 times x minus 1 plus x minus 1 times 5x minus 3 over x minus 1. Your 5 times x minus 1, you're going to distribute that 5. So that is 5x minus 5. The x minus 1 times x plus 1 over x minus 1, your x minus 1's cancel to where you just have a positive x plus 1. Your 3 times x minus 1, you're distributing the 3 to get 3x minus 3. Then that x plus 1 times 5x minus 3 over x minus 1, your x minus 1's cancel. So it's just plus 5x minus 3. From here, combine your like terms on each side of your equal sign. On the left side, your 5x and your x combine to give you 6x, that negative 5 and that positive 1 combine to give you negative 4. On the right side of that equal sign, your 3x and your 5x combine to give you 8x, and that negative 3 minus 3 is negative 6. I would rather move the 6x over to be with the 8x by subtracting it from each side. So I'm left with a positive x value. So that's going to be negative 4 is equal to 2x minus 6. We move the 6 over by adding it to both sides. We get that 2 is equal to 2. 2 is equal to 2x. We divide each side by the 2 in front of the x, and we get that x is equal to 1. Look back at what we said about what x can't equal. We got that x cannot equal 1, but our answer is that x is equal to 1. So this x is equal to 1 is an extraneous solution. So on your test, your quiz tomorrow, you're going to have 2 lines for these answers. One that's just the answer that you get, so you would put that x minus 1 there, and then one that says extraneous solutions with a blank. If one of the answers that you put on the first line is an extraneous solution, you are going to rewrite it in the extraneous solution answer line as well. So it'll go in 2 places. One, the answer, I want just the answers you get, regardless if they're real solutions or extraneous solutions. Then your extraneous solution will also go on the extraneous solution line. If you do not get an extraneous solution, you're just going to write the word none on that line. For number 14, you have 5 over x squared minus 25 plus 1 over x minus 5 is equal to 6 over x plus 5. That x squared minus 25 factors to be x minus 5 times x plus 5. So your least common denominator for this entire equation is x minus 5 times x plus 5. You'll see that that first fraction that you have includes your least common denominator. So you're going to just get rid of your denominator and work with the numerator. So that's the 5. Next, you have 1 over x minus 5. Your denominator of that x minus 5 does not include the x plus 5. So multiply that 1 by x plus 5, get rid of your denominator. Then your answer, that 6 over x plus 5, that x plus 5 in your denominator is missing the x minus 5. So multiply the 6 by x minus 5 and get rid of your denominator. You can also say that your x cannot equal negative 5 as well as it cannot equal positive 5. Because if you set the x minus 5 not equal to 0, you get x cannot equal 5. If you set the x plus 5 cannot equal 0, it gives you the x cannot equal negative 5. From here, distribute the 1, distribute the 6. This leaves you with 5 plus x plus 5 is equal to 6x minus 30. Your 5 plus 5 combined to give you x plus 10 is equal to 6x minus 30. You can move that x over by subtracting it from both sides. So that gives you 10 is equal to 5x minus 30. Then add the 30 over. You have 5x is equal to 40. Divide each side by the 5. And you have that x is equal to 8. That 8 is not an extraneous solution because when we set that x minus 5 not equal to 0 and that x plus 5 not equal to 0, we did not get an 8 for that. If we look at our last question, number 15, we have 2 plus 3 over x minus 5 is equal to x minus 1 over x minus 5. Your least common denominator from this is x minus 5. So that 2 is going to get multiplied by x minus 5. Your fractions, just get rid of your denominators and work with your numerators. So you're going to have 2 times x minus 5 plus 3 is equal to x minus 1. Since x minus 5 cannot equal 0, x cannot equal positive 5. Distribute your 2. That gives you 2x minus 10 plus 3 is equal to x minus 1. Combine your like terms on the left side. That's 2x minus 7 is equal to x minus 1. Move your x over, subtract it from each side. That gives you x minus 7 is equal to negative 1. Move your 7 over, add it to both sides. You get that x is equal to 6. 6 is not 5, so it's good. That is your answer.